All right, I'm going to continue on. I'm just going to make this video 15 minutes. Make sure you watch and pay attention and listen. And 15 minutes, wherever I am, I'm just going to stop and we'll finish in class. So remember the formulas we did and these problems here, examples 1, 2, and 3. We will do this you try it problem in class. In 5th period we already did, but in 1st period we'll go back and do it next class. And I want you to know in 5th period we started these few problems here. So remember these first 1, 2, 3, 4 problems, you do know how to do that. The examples that we covered so far in class, if you want to do those 4 problems just to knock them out, you could. But the rest of them, let's leave until we get to class. Anyway, all right, so let's begin. So a lot of times the goal of what we're trying to do is make a problem look easier. We're trying to do something to it so that it can be easier or look better than it does right now and not be so messy. So I put this little magician here. So we're going to turn this problem just into tangent. Watch what happens. So my first job here, cosecant, secant, cotangent, I can't really tell what's going on with those, so I think what I'll do is change everything to sines and cosines. So cosecant is 1 over sine theta. Secant is 1 over cosine theta, and cotangent is cosine over sine. So a lot of times, everything will change to sines and cosines. So let's get a common denominator. So you got to remember some of your algebra 2 skills. So my common denominator is going to be sine and cosine together, multiplied together. So this fraction right here is perfectly fine. They already had sine and cosine, so I'm just going to leave that 1. Minus this fraction here only had a sine, so I'm going to have to multiply both the top and the bottom by cosine to get this together. So when I multiply the top by cosine, it becomes cosine squared. So 1 minus cosine squared, I hope you recognize back from the Pythagorean identities, 1 minus cosine squared, right, that was one of the transformations I could make to this guy right here. So 1 minus cosine squared is really just sine squared. So I'm allowed to replace that. So I'm going to replace the top with just sine squared. Bottom, the denominator is sine theta and cosine theta. And look at that. One of my sines cancels out with the sine down here. So I am left with just sine over cosine, which is tangent. And yay. So right now you don't really know where to stop, but you want to just make it look better. Next section, what will happen is you'll be told what to try to get it to be, so it'll be a little bit easier actually. All right, so in this problem, you have to remember all of your algebra rules. This numerator right here, secant squared minus 1. Imagine if that was like x squared minus 1. Remember how that can factor into x plus 1 and x minus 1? So do that. Secant squared minus 1 can be secant x minus 1 and secant x plus 1. And the denominator is secant x minus 1. So guess what? There we go. Cancels. And so secant x plus 1 is all I can simplify that to. All right, so it takes a while to get the hang of it, but all right. This next one here, example 6, is going to be a little bit challenging, but let me work on this little piece first. That's going to be the worst one. So do you notice how x minus pi over 2 is backwards of what I see right here? All right. So I have something like this, but it's backwards. So we're going to use 2 identities. We're going to use a mixture of this one that I underlined, and we're also going to use this problem right here. Okay, so watch what happens. So first thing. Now, I'll tell you, I don't really like these that much, so you probably won't see me asking you much with this, but we'll try it here. So I'm going to make this into sine. I'm going to pull out a negative and then have pi over 2 minus x. So I'm going to flip everything around. So pi over 2 minus x. So basically you can see here that by pulling out the negative, I've basically divided everything by -1. So it has reversed the order. If I multiply it back, which I'm not going to do, but that becomes negative, that becomes positive, and it's exactly what I had to begin with. Okay? All right. So with the sine function, remember there was a rule that said sine of -x was equal to negative sine of x. Okay, so I'm going to use that. I have sine of negative this right now. So I'm going to use the fact that basically what I can imagine that's happening is that negative sign is kind of like coming out front and becoming this. So this back part is going to turn into negative sine, and I'm just going to leave pi over 2 minus x. And I'm going to write this sine squared and cosine x back. Okay, so that was the worst part about this. Now, let's see. All right, so now, using my cofunction identities right there, back here, right there, I now know that I can replace the sine pi over 2 minus x with cosine. Okay, so I'm going to do that. So I got sine squared, cosine, minus cosine. And hopefully you notice, oh my goodness, these both have a cosine, so I'm going to factor. So cosine x, I'm going to take that out. Then I got sine squared minus 1 when I factor. So a lot of algebra skills here. And look at that. This piece right here, that is a Pythagorean identity. If you go back, one of the versions of the Pythagorean is, let's see, I think it's, we had 1 minus sine squared, right? I had this part. I can replace that with cosine squared. So 1 minus the sine squared over there is replaceable with cosine squared. So 1 minus sine squared is cosine squared. That's the rule we were telling ourselves. So the only thing wrong with this, sine squared minus 1 is backwards. So if I want to make this sine squared minus 1, I would make this negative cosine squared. Okay. All right, so I'm going to replace that thing in parentheses with negative cosine squared. So I get cosine x. That is replaceable with negative cosine squared. So my final answer is that this all turns into negative cosine to the third. Phew. All right, let's see. Now, number 7. So number 7, everything's in sines and cosines all the way. Already, I mean. And so the best thing I could maybe hope to do here is to, like, I don't know, why don't we get a common denominator and see what happens. So my common denominator is going to be both of these items, 1 minus sine x and also cosine x. So it's kind of like I'm cross-multiplying in a way. I'm going to basically give 1 minus sine x to this part. I'm going to give cosine x to that part, and then put the numerators on the top. So subtraction. So I'm giving cosine to this part, so that's sine x. And I already have a cosine, so it'll be cosine squared x. So by give, I mean multiply. So I'm really multiplying 1 minus sine x by this guy up here. So let's go to the side and do that. 1 minus sine x times 1 plus sine x. So hopefully you notice something special about this. When I multiply this out, 1 times 1 is 1. Then I get plus sine x and minus sine x. Those go away. Then I get minus sine squared. Okay, so that piece, when I multiply it, is 1 minus sine squared. Okay, alrighty. Okay, so at this point, I would change 1 minus sine squared because, you know, 1 minus sine squared is going to be some kind of cosine squared, and I see a cosine squared right there. So let's do that. So back to my Pythagorean identity. My Pythagorean identity says sine squared plus cosine squared equals 1. So 1 minus sine squared would equal, bringing that sine squared over, would be cosine squared. So 1 minus sine squared is replaceable with cosine squared. I'm going to replace this with cosine squared. Okay, so I got sine cosine squared x minus cosine squared over 1 minus sine x and cosine x. So a lot of writing. All right, so look at the top part. I notice there's a cosine squared that is matching. So I pull that out, cosine squared x, factor it out, which leaves me sine x minus 1. In the denominator, I have 1 minus sine x, and I have cosine x. All right, so hopefully you see some cancellation about to happen. Now remember back to algebra 2. If you had a problem and everything was factored, and you ended up with some factors, and one of them was like x minus 3 on top, and let's say you had x plus 5, down here you had 3 minus x, and then you had, I don't know, x plus 2. All right? You may cancel these, but they are the reverse of each other. They're the opposite of each other. So when you cancel them, they make a negative 1. So you would get negative 1, x plus 5 over x plus 2. All right? So I may cancel these, but since they are the opposite of each other, I need to put a negative sign on my problem. So when I'm done, I get negative cosine squared x over cosine x. And I bet a lot of you are seeing that I should go ahead and cancel a cosine with this one. So that is just negative cosine. So who knew that this mess right here would turn into just negative cosine? All right, so let's do one more I think we have time for. Okay, then we'll finish the last one in class. All right, so rewrite this expression 4 over secant plus tangent as an expression that does not involve a fraction. So sometimes you have some choices here. You never know, but you can change everything to sines and cosines. What I'm going to do, a lot of times what you can do is multiply by the conjugate. So remember, the conjugate is when you have the same expression, but you change the sign in the middle. So I'm going to take 4 over the secant plus the tangent and multiply by secant minus tangent on the top and bottom. What I'm trying to do is I'm trying to create perfect squares. I'm trying to create squares so that I can go back and use one of my good old Pythagorean identities. All right, and since this is secant and tangent, it's probably going to be this one, obviously. All right, so let's go back. Where were we? All right, so the top part. I'm not going to multiply the top part. Let's just see what happens. 4, and I got secant minus tangent. But the bottom part was where I was trying to create that Pythagorean business. All right, so the bottom part, when I multiply that out, secant times secant is secant squared. Secant times tangent with the negative, secant times tangent in the middle with the positive, those go away. Then I get minus tangent squared. Okay, if you don't see that, then just take these two items to the side, multiply them, FOIL them with each other. So let's go back to our rule. Our rule on the first page was tangent squared plus 1 equals secant squared. All right, well, all I have is secant squared minus tangent squared. So really, effectively, this is just equal to 1. All right, so I think we've done it. I got 4 secant minus tangent over 1. So if you really wanted to, you could write 4 secant minus 4 tangent, but either of those would be acceptable. All right, I think we got time for the last one. All right, so let's do this last one, and we can talk about them in class and do a couple more if we need to. All right, so rewrite this as an expression that does not involve a fraction. So I'm going to try the same thing. Let's multiply by 1 plus sine x, the conjugate, and 1 plus sine x. So up top, I have cosecant times 1 plus sine x. We might multiply that out later, but the goal was to make the bottom do something because I don't want a fraction. So on the bottom, that would FOIL out to 1 minus sine squared. Okay, so 1 minus sine squared, good old Pythagorean, sine squared plus cosine squared equals 1. All right, so 1 minus sine squared, if I bring that over, well, that's equal to cosine squared. So my change is going to be this. The bottom is going to be cosine squared. The top, I'm going to go ahead and multiply that out, see what happens, because this is going to be cosecant, but cosecant times sine, they cancel. So cosecant plus, and I'll write it out this time, I got cosecant times sine. All right, so remember, cosecant is just 1 over sine. So you multiply 1 over sine times sine itself, they cancel out to 1. So I have cosecant x plus 1 over cosine squared x. All right, so if I don't want it to be a fraction, why don't we do this? Why don't I break this into 2 problems? I got cosecant over cosine squared plus 1 over cosine squared. So this isn't going to be that pretty, but you know, if I bring a cosine to the top, it turns into a secant, you know, because 1 over cosine is equal to secant. So I'm just going to write this 1 on the end as secant squared. And over here, I'm going to bring this cosine squared up, and I'm going to write that as secant squared next to the cosecant. So cosecant and secant squared. So, I mean, you could write this in various ways. You could factor out the secant squared, but really the directions just said write it so it's not a fraction. And so I've done that. And that's it. I'll see you in class. Bye-bye.